Section 4.4, Day 2. Today we focus on sums, differences, and products of complex numbers. Here we have addition and subtraction of complex numbers. They have a real part and an imaginary part, and basically we're just going to combine like terms. So when we look at problem 1 here, we have a 3 and we have an 8. These are both real. We can combine those and we get an 11. We have a 7i and we have a minus 2i. Just like when we're combining variables, the coefficients combine, so 7 minus 2 is 5. That's positive. Okay, but the I doesn't change, plus 5i. And that's our answer, 11 plus 5i. Number 2, here we have some parentheses that are being subtracted. Make sure that you remember we're subtracting both these things inside the parentheses. So the first thing I would do is distribute this negative sign to everything inside those parentheses. So really it turns into negative 4 minus 1 minus I minus 5 minus 9. And at that point, we're going to do the same thing, combine all the real parts and all the imaginary parts. Negative 10 minus 10i. Number 3, okay, here we have the product of two complex numbers. So negative 3i times 9i. Negative 3 times 9, we can combine and we get negative 27. I times I squared. So at this point, we have negative 27 times I squared. Now, remember, anytime we have an I with an exponent, we can simplify it. And I squared is simply a negative 1. Okay, so this is really negative 27 times negative 1, which makes this whole answer just positive 27. Number 4, it's different than the ones we had on the previous slide because there's no plus or minus in between those two parentheses. They're just right next to each other, which means we're going to have to FOIL these two. Okay, we're going to do first, outside, inside, last. FOIL them out and we get this. Okay, once we FOIL, we're going to combine like terms. Okay, these guys go together. And just like the problem that we just did, we have an I with an exponent. We can simplify it. That I squared is a negative 1. Right, so in the middle here, the 6i minus 4i is going to be a 2i. And that I squared switches to a negative 1. So now we have 3 plus 2i minus 8 times negative 1. This is really a plus 8, which means we can combine the 3 and the plus 8. So this simplifies down to a complex number with a real part, 11, putting those together, and the imaginary part, just the 2i. All right, lastly. So two things each have their own parenthesis. This 3 is going to go to both of them. Okay, 2 cubed is 8, I cubed. Over here we have a squared to both of them. 3 squared is 9, I squared. All right, now it's kind of like number 3 up top. 8 times 9, 72. Remember, we add these exponents here when we multiply monomials. And now we have 72i to the 5th. Okay, we have an odd exponent here, which means we're going to have an I in our answer. Okay, and if we switch this out, so let's say we separate that I, okay, and then figure out what's left over. All right, there's 4 left over, which means we have really an I squared twice. There's 2 pairs of I squared. It's a negative 1 squared, and it's going to make that into a positive 1. And so our answer here is 72i. With 6 and 7, we're multiplying two radicals, which is a lot like simplifying radicals, which we did in the last section. So to start off, let's say we break down this 10 and this negative 15. Right, so the 10 is going to become a 2 and a 5. The 15 we can break down to the 5 and the 3, and we're also taking out this I because it's a negative 15. And just like the last section that we did, we're looking for pairs of numbers. So the 5 pairs up, which means the 5 is going to move to the outside. This I is going to be on the outside, and the 2 and the 3 don't have anything to pair up with. Okay, we can't break them down anymore. So we're going to put these back together. We multiply them and they turn into a 6 and they stay on the inside. So 5 on the outside, I on the outside. The 6 comes from the 2 and the 3 that are left over on the inside. All right, same thing for number 7. So we're going to break down the 8, break down the 28. They're both going to have i's. So I out here, and out here from this, each of these parentheses. Okay, and then break down each of these guys. Right, now we could break down these 4s, or as soon as we see that we have 2 of them, we could say that 4 is going to move to the outside. All right, 2 doesn't pair up, 7 doesn't pair up. Those are going to stay on the inside. Okay, so 4 on the outside. Okay, we have 2 i's, so it's really an I squared. 14 on the inside. Now this isn't simplified because anytime we have an I with an exponent, we need to simplify it. This is just going to be a -1. All right, so the whole thing turns into -4 radical 14. Lastly, we have something called rationalizing fractions, and what it boils down to is we're not allowed to have radicals on the bottom of fractions, and we're not allowed to have i's on the bottom of fractions in the denominator. So anytime we have something like number 8, first thing to realize is that if we were to rewrite this, it would look like this, okay, radical 6 over radical 5. These two things are exactly the same. We haven't changed anything, okay, so this is not allowed, and this is not allowed for the same reason. All right, so if we have a radical on the bottom or a fraction inside the radical, we need to get rid of this radical on the bottom. And the way we do that is just by multiplying by whatever's on the bottom of the fraction here. So we're going to multiply the top and the bottom by the same thing, okay? And it's going to be whatever radical is in the denominator. Okay, so times radical 5 on the top and the bottom. Now when we do it on the bottom, radical 5 times itself, it has a partner, and it's just going to equal 5. Moves to the outside, nothing's left on the inside. On the top, now we have radical 30. And that's our answer, radical 30 over 5. Okay, we always try to simplify it if we can, but we can't for this one. So number 9, let's split them up. Okay, when we look at this, we want to see if we can break down either of these radicals. So on the top, square root of -9, this is going to equal 3i, because the square root of 9 is 3, and it's a negative, so we have to move that I outside. Okay, that's an ugly 3i, but that's what it is. All right, on the bottom, we would break down this 8 and do a factor tree on it. Okay, so we have 4 and 2. Square root of 4 equals 2. All right, so 3i on the top, 2 radical 2 on the bottom. Just like the last one, we want to get rid of this radical on the bottom. We only have to multiply by the radical, so we're going to multiply by radical 2. We don't have to multiply by this part. That part's okay. All right, so times radical 2 on the top and the bottom. These guys pair up. Okay, so now there's another 2 on the bottom. These guys multiply. So on the bottom now we have a 4. 2 times 2 gives us that 4. And on the top we have 3i radical 2. Okay, last one, 5 over 3i. Basically, we just multiply by what's not allowed. We're not allowed to have that I. Multiply by the I on the top and on the bottom. Now we have an I squared on the bottom. I squared at this point, we should know is a -1. So we have 5i over -3. And typically, we just write that negative on the top.